Jupiter. Wow, just saying its name makes you think of something huge. And you'd be right, it's the biggest planet in our solar system. A true giant, a king among planets. It's so big, you could fit over 1,300 Earths inside it. Imagine that for a moment, that's a lot of Earths. It's a gas giant, mostly hydrogen and helium, like a tiny star that never quite made it. But its size alone makes it super important. This colossal sphere isn't just sitting there looking pretty, though it is very pretty. Have you seen pictures of its swirling clouds, its famous Great Red Spot? That spot is a storm bigger than Earth. It has been raging for centuries. Think about the power involved there. It's a dynamic, fascinating world with dozens of moons orbiting it like a mini solar system of its own. Some of those moons might even have oceans under their ice. Let's talk about what Jupiter actually does. Its day job, so to speak. Its main tool, gravity. Lots and lots of gravity. Being the most massive planet gives it incredible influence. It's like the solar system's heavyweight champion. This gravitational power is a big deal. It tugs on everything nearby. Asteroids, comets, even other planets feel its pull. This pull isn't just random, it has shaped the very architecture of our solar system for billions of years. One of Jupiter's most famous roles is managing the asteroid belt, that ring of rocks between Mars and Jupiter. Jupiter's gravity likely prevented these rocks from ever forming a planet. It keeps them mostly contained in their current orbit. Think of it as a shepherd for a very unruly flock of space rocks. Without Jupiter's steadying hand, or rather, its gravity, those asteroids might be roaming all over the place. And all over the place could mean heading our way. That wouldn't be good, not good at all. Jupiter also acts like a cosmic vacuum cleaner, or maybe a slingshot. It cleans up debris. Comets and asteroids coming in from the outer solar system often get a gravitational nudge from Jupiter. Sometimes it pulls them in, and they crash into Jupiter. Okay, let's start our cosmic redecorating. What if we had two Jupiters? Imagine another gas giant, just as massive as our Jupiter. Maybe it's in the same orbit, or a nearby one. Double the Jupiter, double the gravity, right? Well, it's not quite that simple. It's more like double the chaos. Our solar system would become a very messy place, a cosmic mosh pit. Planets playing bumper cars. The orbits of all the planets would be severely disrupted. Two such massive bodies so close would tug everything around. Earth's orbit could become highly elliptical. That means extreme temperature swings, freezing winters, scorching summers, or worse, Earth could be ejected from the solar system entirely, sent flying into the cold, dark void of interstellar space. That's a one-way trip to oblivion, not a fun vacation spot. Other planets might collide. Mars crashing into Venus. Anything is possible in this chaotic dance. The asteroid belt would be completely scrambled. Instead of one shepherd, now there are two giant shepherds fighting over the flock. Asteroids would be scattered everywhere. Now let's try something different. What if Jupiter wasn't so Jupiter-sized? Let's shrink it down, way down. Imagine Jupiter in its current orbit, but only the size of Earth. Still a gas planet maybe, a mini Jupiter, but with much, much less mass. What happens then? Well, its gravitational voice would become a whisper, not the booming command it has now. This tiny Jupiter wouldn't be much of a bodyguard. The asteroid belt would notice the change immediately. That strong gravitational shepherd, gone. Replaced by a much weaker influence. The asteroids would start to drift more. Their orbits would become less stable. More of them would likely stray into the inner solar system. Yes, that means more potential impacts for Earth. Our planetary shield would be significantly downgraded. It's like trading a giant, strong bodyguard for a small, less capable one. Not ideal when space rocks are flying around. Section 5, Scenario 3, a lighter heavyweight, Saturn steps in. Let's consider another swap. What if we replace Jupiter with Saturn? Saturn is still a gas giant, it's big, it has amazing rings. But it's not Jupiter. Saturn has about 1/3 the mass of Jupiter, so it's a significant downgrade in terms of gravitational muscle. Think of it as trading your heavyweight champion for a middleweight, still strong but not the same dominating force. How would this change our solar system's dynamics? Would Saturn be up to the task of protecting Earth? Let's investigate this cosmic trade. The asteroid belt would definitely feel the difference. Saturn's weaker gravity would mean less control over those space rocks. While Saturn would still exert influence, it wouldn't be as effective as Jupiter. The belt might spread out a bit more. Some asteroids might be nudged onto more eccentric orbits. This could lead to an increase in asteroids crossing Earth's path. So, yes, the impact risk for Earth would likely go up. Not as dramatically as with a tiny Jupiter, perhaps. But still, an increase is an increase. We like our impact risk low. The orbits of the other planets would also shift. Uranus and Neptune in particular would feel the reduced pull from Jupiter's old spot. Section 6, Scenario 4, a star is born, Jupiter ignites. What if Jupiter wasn't a planet at all? What if it was massive enough to become a star? Jupiter is mostly hydrogen and helium, just like the Sun. It's sometimes called a failed star. It would need to be about 13 times more massive to start deuterium fusion, becoming a brown dwarf, or about 75 to 80 times more massive to become a true hydrogen-fusing star like a red dwarf. Let's imagine Jupiter gets that extra mass somehow. It ignites. Our solar system suddenly has two stars. A binary star system. That sounds exciting, right? Maybe not so much for life on Earth. If Jupiter became a small star, like a red dwarf in its current orbit, the outer solar system would be cooked. Saturn, Uranus, Neptune, and their icy moons would be blasted with heat and radiation. Their atmospheres would change dramatically. Ices would melt or sublimate. It would be a completely different environment out there. No more serene cold giants. Instead, they'd be bathed in the light of two suns. Their very nature would be altered. A dramatic transformation. For Earth and the inner planets, things get complicated. We'd now have a second, albeit dimmer sun. This would add extra heat and light to our planet. Our climate would go haywire. Average temperatures would soar. Section 7, Scenario 5, the dark side, Jupiter becomes a black hole. Alright, let's get even more extreme. What if Jupiter with its current mass suddenly collapsed into a black hole? Poof! Squeezed down into an infinitesimally small point. A black hole with the mass of Jupiter. Sounds terrifying, doesn't it? A black hole in our solar system. But wait, gravity is gravity. If the black hole has the same mass as Jupiter and stays in the same orbit, the planets from a distance wouldn't notice much of a change orbitally speaking. At first anyway, Earth would continue to orbit the Sun just as it does now. The black hole's gravity would be the same as Jupiter's at that distance, but there would be some key differences. Jupiter has a powerful magnetic field. This black hole wouldn't. Jupiter reflects sunlight. This black hole would swallow light. It would be an invisible gravitational point essentially, unless it started accreting matter. If gas or asteroids got too close, they'd be pulled in. They'd form an accretion disk, heating up and emitting X-rays. Then we'd see it. A bright, energetic point where Jupiter used to be. That would be a new source of radiation in the solar system. Not ideal. The real danger comes from things getting too close. The event horizon of a Jupiter-mass black hole would be small, about 3 meters in radius. But anything crossing that boundary is gone forever. Jupiter's moons would be in big trouble. Section 8, Earth's wild ride consequences for our home planet. So, we've played cosmic Jenga with Jupiter, we've made it bigger, smaller, a star, a black hole. What's the bottom line for us here on Earth? In almost every scenario, it's not good news. Our planet is in a delicate balance. Jupiter, as it is, plays a key part in maintaining that balance. Mess with Jupiter, and you mess with Earth's stability. And that means messing with our ability to live here. It's a stark reminder of our interconnectedness, even with a planet hundreds of millions of miles away. The most common threat in these scenarios? Impacts. More asteroids, more comets heading our way. If Jupiter is smaller, or replaced by a less massive planet like Saturn, its shielding effect weakens. The cosmic shooting gallery opens for business. Our atmosphere can protect us from small stuff. But bigger impacts? Those are extinction-level events. The dinosaurs learned that the hard way. We really don't want to repeat that experiment. A steady stream of large impactors would make Earth uninhabitable. Civilization would crumble. Life itself would struggle to survive. Then there's orbital stability. If Jupiter becomes a star, or if we add another Jupiter, Earth's orbit goes wild. We could get too hot, too cold, or even flung out of the solar system. Our current orbit gives us liquid water and a stable climate. Relatively stable anyway. Section 9, Conclusion Jupiter, just right for us. So after all this cosmic remodeling, what have we learned? Jupiter is not just another pretty face in the planetary lineup, it's a crucial player, a vital component of our solar system's machinery. Its current size, mass, and orbit are in many ways just right for us. Like Goldilocks finding the perfect porridge. Not too big to become a star, not too small to be ineffective. Its gravitational influence is a powerful force for stability, a force that has profoundly shaped the environment of the inner solar system, and by extension the conditions on Earth. Jupiter acts as our cosmic bouncer, our celestial shield. It tirelessly patrols the solar system, sweeping up dangerous debris, deflecting rogue comets and asteroids. It sculpts the asteroid belt, keeping most of its inhabitants in check. Without this constant vigilance, Earth would be a far more perilous place, a world pummeled by impacts, making it difficult, if not impossible, for complex life to evolve and flourish. We owe a debt of gratitude to this distant giant. It's a silent protector, working day and night, for billions of years. Thinking about replacing Jupiter highlights its importance. Whether we imagine another giant, a smaller version, a star, or a black hole, the consequences for Earth are almost universally dire. Our solar system is a finely tuned instrument,